So this is our fourth video on the subject of limits, and this video is a quick one that just illustrates some of the problems with the methods that we've used until now, which were to basically sort of guess or guesstimate the limit of a function by looking at the values of the function nearby. And we see the limitations, especially when we look into periodic functions. And our most common example for periodic functions are the trigonometric functions like sine, cosine, tangent, and so on. So basically, we'll look at two quick examples, one where the guesstimating is okay and the other where it's not. So in this first example, y equals sine x divided by x. So clearly this is when we look at the limit when we take x to 0, we have some kind of issue here because we have x in the denominator. So we do anticipate some trouble. Here in this first graph here on the left is the curve that shows the value of the function for all x's that are not 0, and it goes smoothly through this point 1 here, but strictly speaking it shouldn't be defined as a at that point unless we define it individually at x equals 0 to be equal to 1. If we look closer at the function, so we go to smaller x's in this right-hand curve, what we see is that the function is smooth around x equals 0, and the limit from both sides, the limit is 1, equal to 1. And so in this example, we do have a sort of a periodic function. You see it beautifully here. Despite that, when we go to x equals 0, where we might have some problems, we do see smooth behavior. So this is an example where things work the way we're used to them working. Now let's look at another example where things are not as simple. This is the example of the function y equals sine of 1 divided by x. And again, when we take x to 0, we anticipate some complexity because 1 divided by x is infinite. But in this first curve here, we've graphed the function between -4 and +4, and you do see that there's some kind of up and down behavior here. So the function is oscillating quickly up and down, and that is because as x goes to 0, 1 over x becomes very large, and so we're going very quickly between the oscillations of the sine function. What happens if we enlarge this region here? So we're going now from -1 to 1. Well, we see a very similar curve. We still see those oscillations. So we can look a little bit closer, and as we get closer, we see more and more oscillations. Here we're between -0.1 and +0.1, and the same thing happens as we go even smaller. So basically, what we see is that the closer we get to 0, the more difficult it is to actually pin down the value of the function, because we're getting all these very, very tight oscillations. And they actually get tighter and tighter as we go closer and closer to 0. So in this case, we can't find a limit. There actually is no limit to the function as we take x to 0, because the function continues to oscillate as we hit that limit. So this is an example of a periodic function where finding the limit is impossible.